Okay, good evening to you all. So I will be explaining the question I dropped the other day. Now this is a question. This is a typical UTME question in physics. And the topic you can get this question is electricity. So here we are told that if the key in the circuit below is closed, the current delivered by the battery is dash. So we have a circuit here and we have three resistors. This is the first resistor, second and third. And the EMF or the voltage that runs through this circuit is 15 volts. So initially, you can see that the key is open here. The question asks us that what will happen to the current when this key is closed. So when this key is open, it means that this one is not having any current. That is, no current is passing this through this one. So for us to determine the current delivered by the battery when the key is closed, like what will happen to the current of the battery when the key is closed, we have to first determine the current when the key is open, that is when this key is open. So we have three resistors here, 1, 2, 3. So initially when the key is open, current is only flowing through this and this. And don't forget, these two resistors, they're actually in parallel. Why? Because they are connected by a junction. A junction is a point along an electrical circuit where more than two wires meet. But this one ohm resistor and these two connected together, they are in series. Is that okay? Now let's proceed to the question. Our total voltage is 15 volts. The resistor, the total resistance when the key is open is going to be this plus this, because we are not determining this. This one is out of it because the key is still open. No current is flowing through. And for resistors in series, the total resistance is R1 plus R2, that's 4 plus 1, that's 5. Now from your Ohm's law, V equals IR, when you make I the subject of the relation, you have V over R, which is 15 over 5, and you have 3 amperes. So it means that when this key is open, the current delivered by the battery is 3 amperes. Now let's now determine the current delivered by the battery when the key is closed. Now when the key is closed, that is key closed. Now when the key is closed, it means that this terminal here will be closed. Can you see that? This terminal here will be closed, meaning that current will now flow through this terminal. Now for us to determine the current in this case, now we have to first determine the total resistance, because we are not going to consider this in our equation. So in this case now, our voltage, which is the EMF, still remains the same. Don't be confused. I'm referring to this voltage as EMF because we are talking about a cell, which is a battery. But we are still going to get there. So just know that whenever you are referring to a cell or battery, the total voltage at once is called EMF, electromotive force. Now let's determine the total resistance here. First of all, for you to determine the total resistance, you have to short circuit it. Why? Because you have two parallel resistors and one series resistor. These two are in parallel. So first convert this one. Determine the total resistance here that are in parallel. Don't forget the key is now closed, meaning that current is flowing through this. So we have to consider this resistor here, this 4 ohm resistor here. So now let's short circuit. How do you short circuit? Just say by short circuiting. When we say short circuit, it means I want to consider the resistors in parallel first. And don't forget, our equation for resistors in parallel is that total resistance, 1 over total resistance equals 1 over R1 plus 1 over R2. Is that okay? And that's equal, so these are the two resistors in parallel, and that's 1 over 4 plus 1 over 4, and that's 1 over 2. This one is for the one in parallel. So after getting your answer, you now what? Inverse it. This is 1 over RT for the resistor in parallel. So when you inverse it, you have that the total resistance in parallel is now equals to 2 ohms. Is that okay now? This one is a total resistor. That is, these two resistors connected in parallel, they will offer a total resistance of 2 ohms. Now let's now determine the total resistance when we consider this 1 ohm resistor. Is that okay now? Now the total overall resistance, which is big R, the total overall resistance, we can make that R alpha, will now be equals to this one plus this one we got from this short circuit, that is from these two parallel resistors. So that will be 2 plus 1, and that's equals to 3 ohms. Are we there? So don't forget, when the key was open, the total resistor was 5. But when the key is now closed, the total resistor is now what? 3. It means that when you had connections in parallel, it actually decreases the resistance, sorry. Now let's now determine the total current now. Still using the same expression, V equals IR from Ohm's law, meaning that our I, which is the current, equals V over R. So our I equals, what is our V? Our V remains constant, which is 15, but our resistance now has decreased to 3 because the key is now closed. So 15 over 3, and that's equals to 15 divided by 3 is what? 5 amperes. So now let's now look at it. When the key was open, the total current delivered by the battery is 3. That is 3 amperes. Can you see that? And when it is closed, it is now 5 amperes. So what happened to the current? It increased from 3 to what? 5 ampere. So the current increased by 2 ampere. So according to this, option A is correct. Option A is correct. Option A is correct. Is that taken? The current increased from 3 amperes to 5 amperes. It increased by 2 amperes. Simple as that. Now I believe you gained something from this. So these are the kind of short video clips I will be sending to you when we come across tough UTME question, or perhaps some question that will be tricky. And don't forget, we'll be starting our free UTME class this month on the 23rd of September. So I urge you all to participate and prepare for next year UTME with us. I wish you all the best in your forthcoming examination. If you are preparing for next year JAM, I will advise you to start reading now for you to have a good UTME score. Once again, I wish you the best of luck. My name is Alchemist. Have a nice day.